What's going on, everyone? Today I'm going to give you a primer on bash scripting. Now, I've been doing bash scripting for probably several months now because I've written some of my own programs, some of my own scripts. Modifying Arch and doing different things requires a good working knowledge of bash and how to do things in the shell. And pretty much the commands that you run in the shell, print working directory, echo this, grep that, sed that, all those different things can be scripted. You can do these things in scripts and perform actions and complicated operations and text manipulation with bash scripting. It's a very powerful language. It's got a very weird syntax, a lot of weird quirks, and just some things to know about it. And I'm going to give you an overview of a lot of the functionality. I'm not going to be going over specific functions or built-ins, and a built-in might be like the grep command or printf or sed or awk or whatever. I'm not going to go over those in detail in this video. I'm going to go over more of just like how the language works, because these built-ins like grep and sed, those are things are written in C, and bash is basically glue for C programs. So the logic and the things that combine those programs to produce programmatic output and text manipulation is what I'm going to go over today. And just some weird things that I've come across and that I now understand how to use and implement. And, I'm not, this is not the end-all be-all video. It's not going to be completely comprehensive. It's an overview and a primer. And so I might even get some stuff wrong. And if I do, just let me know in the comments below. We're all still learning. But based on what I've been doing in the last few months, this is what I've picked up so far and just some good working knowledge of bash. So to start off, every single file that you run as a script in your system, you could do a Python file, an R script, a bash file, any sort of script executable. And there's honestly a lot. They all have to start with something called a shebang. You could do this with Python, awk, R, bash, ZSH, whatever. So the shebang is the hash symbol followed by a bang or an exclamation point, and then you list the binary of what your shell is actually going to be. In this case, most people typically just do bin bash. This will work fine. Like currently I have this one commented out, so you can ignore it. If I just have a variable here printing out the value of hello, and I'll go over variables in a second, but if I just go over and execute this, it's going to execute fine. If I change that shebang and I make this the main one, user bin env or environment bash, it does the exact same thing. But the difference between these, and somebody in the comments, please feel free to let me know if there's more specific reasons, but from my understanding, bin bash is mostly just to make your scripts more portable in the macOS environment, due to the fact that a proprietary business cannot sell all of the built-in software that GNU, Linux, and just open source software, basically the licensing, and I think it's GPL 2 or 3, prevented Apple from like shipping their products with some of these utilities because they were copyleft. So some of these things are not included. You as the user can download them, but Apple could not sell you the product with them already inside. And at least with the shebang, bin bash refers to an older version of bash in macOS, so it might actually break some of your scripts, especially if you're using bashisms and non-POSIX compliant shell commands in that use newer features that their old version of bash does not have. I'm not going to get too heavy into that kind of stuff. POSIX is a big thing I'm still learning a lot about, just things that were basically more portable scripts. So using user bin env bash tends to be a more portable option of starting your scripts with. Now, again, I'm not an expert on any of this, so please let me know if I get anything wrong so you can help everyone else understand and so I can learn too. All right, so the first thing we're going to cover is variables. Variables are very easy. You have, the name of the variable, an equal sign, and then whatever you're assigning to that variable. Now, I just have this variable being assigned to the text string hello, and I'm echoing it out. And you saw the result of that. It echoes out the word hello to the terminal. Now, if I comment that out, if I can type today, and what happens if we have spaces between the equal sign and the variable name and assignment? and what it's being assigned to. Well, you can see that based on my IntelliSense or the syntax highlighting, it's no longer that teal color. Now, if I run this, it's an error. So when you're doing variable assignment in Bash, you don't want spaces around your equal sign. Because now if I remove that, it does exactly what we want, and it actually displays that string. Now, something else to know is you can actually add the output and results of commands, different built-in Bash commands like print working directory, which I have here, pwd, and assign that result or value to a variable, and then echo out that variable. So what happens if we do that? That is not my working directory. So this is going to go into our next section called command substitution. I can't just put the name of the built-in command and then assign that command to a variable. I want the output of that command assigned to the variable, but if I just list the name like I have here, this is not going to work. So what I have to do is something called command substitution. What that looks like is if I have pwd here, I actually need to add a $sign and then parens around this. And this is saying, hey, execute this command and then return the output and then assign the output to the variable my_dir or directory. So if I run that now, it'll actually give you my current working directory, which is my home directory. So let's go to the next item. Now with command substitution, I'm going to get into quoting in a section or two. Sometimes you might want to quote variables inside your command substitution. Sometimes you want to quote your entire command substitution $paren structure. It depends. There are a lot of different examples and things you can do with command substitution. So next I'm going to get into arrays. This is something I picked up actually while I was working on my Flash script. If you want to see some of those things, you can check out one of the cards above in the video. Arrays are interesting. You can assign a value to it, and based on a delimiter, in this case the internal field separator I think is just defaulted to a space, I actually have to use parens around this value, and then I can access each individual array item with this syntax: a $sign, curly braces, the name of the array, and then in square brackets the index. So in this case we thankfully have a language that does use index 0. Some of those weird ones that start with index 1 are an abomination. So index 0 accesses the first value, in this case hello, and the second index 1 accesses the second value world. So let's see the output, hello and world. So this value is it should be a string, but we actually have to put it in these round parens. But what happens if we actually add a string value with double quotes? So the array value is equal to a string hello world, and it's double quoted. Oops. It just outputs the entire array. So the index 1 is the entire item, and then the second index value, number 1, is nothing. It's null. So when you're actually going to do a string like this, you need to, or if you're going to do multiple values, you need to actually input a value within the parens. Now, something I haven't figured out, I wonder if you can just put a comma here and do it that way. Nope. I guess you might have to set the internal field separator variable. But in any case, there's also some other syntaxes. This isn't all of the things about arrays, but you can also do a wildcard as the index and then do a hash mark before the name of the array. And what that's going to do is count out how many items are in the array, in which case we have 2 indexes. So index 0 and 1, so our total of 2 values within the array. So that would be useful if you're going to do a test and make sure that the proper amount of arguments are within an array. You can make use of that however you'd like. The next thing is quoting. Quoting is a very important and sometimes forgotten or neglected piece of information that you need to do with Bash and its variables. So if you have a working directory, if you have a file name, or say you have anything and it has spaces or sometimes maybe illegal characters, if you have spaces, a space is usually a delimiter in Bash. So if you had a space between certain commands in your command line, if I wanted to do echo this, it would just do the word this. But if I did echo this word, it'll do that. So it will work. But sometimes when you're doing different commands and they have spaces, or you're doing something with directories, so make dir, let's just say the name of my directory is my directory. Okay, let's see what happened. So I have my and dir. So maybe that wasn't your intention. Maybe you just wanted a directory named my dir, but it's just one single word and it just has a space in it. But because the space is the delimiter, it actually creates two different directories. So that's the unintended consequence of when you might need to double quote your value. In this case, you can double quote command substitution, you can double quote variables, and the best practice is double quote your bash variables unless there is a very explicit and intentional reason to not quote them or to single quote them. In which case, if you're going to do a variable, you usually don't single quote, because a single quote is a literal string. It's saying print out exactly what you see inside the string. So in this case, we have two different print working directory command substitutions. So this should print out home/Brian, or my home directory. Now we have two of these commands. Let's see what the output is. We have a double quote and then we have a single quote. You can see the syntax highlighting, so you might be able to guess what's going to happen. There we go. So you can see that the first one actually executes the command substitution and is double quoted, so that way if there was some weird output in here with a space, it would actually still output the string as intended. Now if you have a single quoted working directory or this single quoted command substitution, it outputs that whole command substitution as a literal string, special characters and all. Sometimes you might want to do single quotes, such as if you're doing like a backslash, a literal backslash character, or some protected characters like you're inputting some HTML and CSS, which uses a hash mark and angle brackets. You might actually want a literal string. So it depends on your situation. Next, we're going to do math. So Bash can do math. It's not as just simple as, in Python, 4 plus 4, and it outputs a result. In Bash, your math is actually, you can do it two ways. You can do just a double paren, and by itself, sometimes that will work. In this instance, because I'm assigning this output to a variable, I actually need the $sign, or at least it threw an error for me earlier. So this is what I figured out. You can just do it by itself, and there is an example we'll go over later that shows this. But by itself, if I want to assign the result of the math operation of 4 plus 6 to the variable result, and then print out the variable, we can do it this way. Now, you can also see I have two echoes here. I'm echoing out the result variable, but one of them is double quoted. But what happens if we're double quoting a variable that just contains a number? Let's see. Nothing happens. It's exactly the same. It is text. Now, if you know it's a number and you know what the output is going to be for sure, and you don't want to quote the variable, and you know that you're never going to have a space and it's going to be a value like this forever, you know what? Feel free to not quote your variable. But the best practice is, unless you have that very explicit and exact reason, always double quote your variables. Always. It's always the safest bet. So next thing is a very commonly used feature, and that is the test statements. So the test statement runs a test. The built-in is actually just this forward-facing square bracket. That is the name of the built-in. If I go to, let's just say /bin, we get all of these binaries. So let's just look for ls, things that look like that. So there we go. Let me just put it there at the top. So you can see we actually have a built-in that's literally named forward-facing square bracket. That's the executable right there. Now if I go, I can't look at it because it's a binary executable, so you're not going to be able to make sense of any code here. But that is the name of the test built in. Now the reason why we have the closing square bracket is simply just for readability. So the way you can read this is the square brackets are the test. Test is taking an argument such as, okay, what are we doing here? They can take in certain variables, and then the test built-in excuse me, always expects to see the closing square bracket as its last argument. That is just how it's designed. It is designed to see that last square bracket as its ending argument. Now, it's expecting that, but honestly, it's just there so it's easier for us to read as a single, testing unit. So what this is doing is the Z option is really just, I'm testing for a null string. Is the string I'm putting next to this flag null, meaning is it an empty string? Now, when you're doing tests, you actually want to have spaces between the square brackets and its internal contents. If you don't, I believe it throws an error. So I also have this whole test thing here, which should return either true or false in a command substitution, and I'm just echoing it out. Now, there's no variable in here. I don't need to double quote this, but I mean, technically you probably could, and it would still work exactly the same. But let's see the output. Nothing. So true and false is what happens. Now, honestly, if things are true and everything is hunky-dory, everything's good, you want silent output. Nothing is wrong, no errors, so be quiet. And that is how the test built-in works. So because this passed because this failed, it actually is, this failed because this is not a null string. So really it just executes and then there we go. So actually I'm wrong about that one, my bad. But this one is actually true. The string is null. There is no string in there. So if I run it, it's the exact same thing, but no output, but we now know it is a failed, or this is one is true and this one was false. Now, where you can actually see this is when you do it with if statements, and we'll get to that in a second. Now, when you actually have a passing test in this instance, so flag Z and a null string is true. This Z is saying, is the string null? The string is empty, so yes, it is a null string. This is true. But when you add a bang or an exclamation point before the Z flag, that is, exactly how it is with other logical operators and operations in other programming languages. It's basically flips the Boolean value. So it's saying, yes, this is true. This is a null string, but we're going to say false because we have a bang here, and it's going to switch the Boolean value. I run it, same thing, still quiet. So I can go down here. And now, one thing cool that you can do, and if you don't want to do all of the code for an if statement, you can just do a simple, test like this, and then have the double ampersands. A double ampersand is saying, hey, if the first thing successfully executed, or in this case, if the test is true, then also run the command after it. If you just do command, semicolon command, it'll run every single command regardless. So in this case, let's just do, I will show you this example where I can say, I'm going to insert a semicolon, and I'm going to make the null string not null. All right, so let's see what happens with this. All right, is the string null? Yes, it is. This is true. So therefore, we are also going to execute hello, hi. Correct. So the output is indeed hi, because this executed effectively, it executed and is true, so therefore we also run the subsequent command, echo hi. Now I'm going to comment that out. What happens if we say, is the string null? No, it is not. This test fails. But we have a semicolon, which basically says run the first thing, then also run the second thing, etc. It just says run everything. Do this command, then this command, then this command. So I can do that. It also echoes hi. It's going to execute regardless. So if you want a test condition to say, hey, this has to be true before you do anything else after it, and if it's false, don't do those actions, you want to use the double ampersands, which is basically just the word and, or the Boolean operator and. Now the semicolon is also very useful if you're stringing together multiple commands. For instance, this is just as an aside. I aliased certain git commands like git add, git commit, git push to do manipulation in my repos. So commonly I'll just say, git add, the file, semicolon, git commit, semicolon, git push, and I'll just run all of that. It'll prompt me for my git commit message. I'll enter that, and then it'll prompt me for my password. I enter that, and then it just pushes everything to my repo. But it's a single one-liner, very concise to easily just push new files up to my repos. So semicolon does have its purpose and its place. So don't think that it shouldn't be there or shouldn't be used. So next is if statements. If statements are interesting, and one of the weird things about some of the conditional operations in Bash is that you also have to end the operation. Like normally you see if, then, else, else if, or those different things, but with Bash it has to end with the name of the statement backwards. So in this case, if statements end with fi or fi, if, fi. And the same thing goes for case statements. Now, I didn't do this in the example, but if you wanted to do else or else if, all of those are valid if operations. And where if really shines is when you work with tests. Now, you could do this with variables and say just like, if the variable exists, if the variable is something. I think like even if a string, if it is not a null string, it is then true if it exists. I think any number is true unless it's 0. Correct me if I'm wrong. So you could do if statements with things other than the test built in, but commonly what you see is people testing things as their if conditional arguments. So in this case, I'm saying if the string is null, then echo hi, end the if statement. Is this going to execute? We know that it is not because the string is not null. Now, if the string is null, it is echo hi. We now get hi. So if the string is null, and that's true, and 0 equals 0, which is also true, then echo hi. The first one is this one. I'll just comment that out so it's not confusing for any beginners. So if both of those conditions are true, because we're using the AND logical operator, it does return the output hi. Now with Bash, we, just like most programming languages, also have the AND and OR operator, as well as the NOT operator, which is the bang symbol. So in this case, if the string is null, true, or 0 equals 0, also true. So in this case, one of these conditions could be false. In fact, let's make one of them false. I'm going to make the string not null. So in this case, this test fails. This whole test in here is now false. Or if this one is true, then echo hi. Run that. We do get output. So in this case, you can actually do logical operations. Now, for those of you who are immediately going to jump on me for not doing a double test bracket, I do still do some things that are Bash-isms. I'm not 100% sure on what all of them are. You can do Bash tests like double brace and then do, test and test within double brackets. This is valid Bash. This is a Bash test, but this is a Bash-ism. What a Bash-ism means is that if you were running a shell other than Bash, this is not going to work. This is not POSIX compliant. It is not portable. It can break between different versions of Bash even. So typically I will avoid these things and do POSIX compliant tests like these square bracket tests. That is just another thing to look into. The whole world of POSIX stuff is still something I'm researching, but I typically never use the Bash tests. I mean, the syntax would be preferable if you could do just complete Bash and you're writing a Bash script and you know it's going to be Bash only with a certain version of Bash, go nuts. You could just have to, make sure you specify you have to run Bash to use this. You have to run this version of Bash to take advantage of these new features. And other than that, you're good to go. So next thing I'm going to cover is case statements. These are some of my favorites. I love how you can use these in your commands. So case statements, basically says, hey, here's a value. Now find the value in one of these commands or one of these, match the value. Here's an input value, match it with one of these items, and then do subsequent actions. So in this case, we're going to check our file type and then say, hey, I encountered this file type. What do I do? So in this case, our file type is going to be .md for Markdown. So you can see the case in here. Oh, we have an option for wildcard .markdown. So it says, okay, find my file type. My file type is Markdown in these lists of file types. Ah, here's my file type. Echo, you chose Markdown. Okay. Save. I did indeed chose Markdown. So with case statements, you have case, your variable, or what you're going to be looking at. And we're double quoting our variables here, in, and then you list out your options. Your options are whatever your option is, then a closing paren, whatever you're going to do. So you could list out a very long, complicated script here, or just multiple actions joined with double ampersands for the AND operator, or just do semicolons, execute multiple operations, etc. The important thing is that you end your operation with double semicolons. So we chose Markdown. We got the output that we wanted. That's awesome. Now we're going to change it to a tex file. You chose a tex file, and LaTeX is best. Now you can see that here the output was you chose a tex file. Bang. But we also can pipe with the pipe operator. And again, anything you can do in the command line, you can script, which means that piping output to other commands, chaining all these commands, performing complex operations, awk, grep, sed, all of these things are possible in scripts. So we're piping this echo output into the sed command and doing a regex replacement. We're saying, hey, find the bang operator, or find the bang, and there it is, and replace it with all of this text inside the forward slashes. And we did that. You can see the output is exactly that. And that's all it did. It just replaced the bang with this extra text. So now I'm going to change it to RMD. So if you have an R Markdown file, here's another cool thing I really love about case statements. You can use regex. You can use globbing. So the globbing is just like these wildcards. We'll get into globbing later. It's in this training. But wildcards. So if you have square brackets like this, that says any single one of these options. So you could have lowercase r MD, uppercase R MD. Both of these options will hit this same command. So let's see what this is. First off, we're starting with the lowercase r. Save and execute. I chose R Markdown. Yes, I did. So now let's do the other one. Capital RMD. Works exactly the same. It is captured. Bash is case sensitive. If your variable is all uppercase and you type it lowercase, they are not the same variables. So this means that you can use basic regex with case statements. This is the extent of what I've done with case statements in regex, is just using the wildcard and then operations like this to find certain letters for like the number or the beginning of a file type, etc. So that works. So let's just say file type is equal to something that isn't in this list. So let's just say, C. Do you see a C option in here? No, there's no C option. So with case statements, it's going to search through all of your options top to bottom before it actually finds something. So a good practice is to, at the bottom, put a wildcard, just single wildcard, nothing else. What this is basically your default option. It says, hey, you don't find an option and you get to this point, then do this thing. This will work on any other output. So we don't have a C file type in here because there's no option. So it's going to say, oh, okay, here it is. Go to the default. You chose nothing. This is the default. And that is the output of that command. Now, just like the if statement and fee, you have to use case statement or case backwards, ESAC. Weird that Bash does that, but that's how it is. Case statements are really fun. I really enjoy those, actually. So next we have a variety of loops. The first one we're going to do is the while loop. So counter equals the number 1. So while the counter is less than or equal to 10, do these actions. The actions to do are echo the number or echo the counter, and then iterate the counter plus 1. So you can see that we have the double parens here. This is doing bash math. And inside this, you notice that if I actually remove the space here, it'll actually say, this paren is an error. But actually, if you execute this, it will work as intended. It's weird. I don't know why it's doing that. But if I indent it correctly like this, it works just fine. There we go. It works. But it's saying that, hey, we're going to add this, this variable plus equals to itself plus 1. Counter equals counter plus 1. That's what the plus plus operator does. It's an incrementer. So while this counter is less than or equal to 10, echo the number, iterate it, and add 1 to it, and then do the action again. Repeat. And then when you're finally done with doing that, because now counter is greater than or equal, or it's greater than 10, then echo all done. So let's do that. So we can see every single number, 1 to 10, is all echoed out. And then we also have all done after it's finished executing. Now, as soon as it was equal to 11, because while counter is less than or equal to, it's going to do this before it actually runs these actions. So that's saying that if we did a do or until, one of the other loops actually includes an additional value. I don't really honestly do too many of these loops. I usually just do for loops. Yeah, I'll just leave it at that. I mean, if you're doing bash scripting, you're probably going to get familiar with loops in general. So let's just do the until loop. So the until loop is saying until the counter is greater than 10. So it has to be greater than. If we said less than or equal to 10, then as soon as it hit 10, you would only get 1 through 9 printed out before it says all done. So until the counter variable is greater than 10, do the same actions, then echo out all done when you're finished. And it does the exact same output there. So let's see what happens if we change it to less than or equal to. I'm sorry, greater than or equal to. So there we go. That's what I was talking about. If you want it to be greater than or equal to, it'll only print out 9, which is why we said greater than. So now we get all 10 like we wanted. Next thing we're going to do is a for loop. So we have the variable names, and it includes a literal string with single quotes of 3 spaced names of South Park characters. So for name in names, so this is not the name of the variable. This is just, this could be X, for instance. This is sort of like the weird list stuff you can do in Python, where if I just replace that with like X for X in names, this would still work. And for each name in the names variable, do these actions. The action, echo the name out. Repeat for each name, then echo all done. Let's run this. I guess we actually do need names. My bad. See? Learning experience right here. Not sure why, but okay. Python is different then. So for name and names, echo out the name, echo all done. Now, why did we not double quote names here? Well, that's because we actually want it to be split in spaces. So if we actually double quoted this, it would not give us the exact same output where we had a name on each line. They delimited by the space character. If I execute this, it's a single name because the double quotes prevent string splitting when the space is the delimiter. That's why it's actually unquoted. In this case, this is what I was talking about. When you have a deliberate reason to not quote your variables, this is when you might do it. Next thing I want to talk about is brace expansion. This is one of my favorite things about the shell. So what brace expansion is, we'll first cover ranges, and then we'll get into brace expansion. But it's basically the same thing, is that inside these braces you can do things like for value inside a brace pair 1.5. This is actually similar to Python, or maybe Python took it from this, or maybe this is similar to C. You know what? Who knows? So brace expansion in this case is saying 1 to 5, all the values between 1 and 5. For each of those values, do these actions. The action being echo out the value, then when you're finished, echo all done. If I do that, 1, 2, 3, 4, 5, all done. This number could even be 100 if you wanted it to be, and it would still do it. So one of the things I love about brace expansion is that you can do things like this. So I have the touch command here. And with the touch command, you're going to create a file. You could either use touch and you could say, hey, change the modified time of this file. But if you actually give it an argument of a file that doesn't exist, then it's going to actually create that file. If you wanted to create multiple documents, such as, before we do this example, I'll do this one. So say you wanted to touch, let's just say in curly braces, because inside curly braces is what we're expanding out. And it works with globbing in a way, so let's just bear with this example. File1, comma, file2, comma, file3. Now, when you're doing these brace expansions, you do not want spaces. You want to comma separate your arguments and no spaces. Remember, space is our delimiter. It causes wonky behavior. In this case, just do your file names separated with commas within braces. And then what are we going to put at the end? We're going to put a file type. So let's do .md. So .md is not in the braces. In this case, we're saying, hey, for each of the items in these braces, touch file1.md, touch file2.md. And it's going to do that and expand the brace. So it's basically going to run the touch command 3 times, because we have 3 arguments in here, and create 3 markdown files, each of them with one of those names. If I actually ran this script, if I can actually run my script, you can see that now, right here, I have those 3 markdown files. So now I'm going to show my original example. So let's say we have an ending, and you wanted to have a file type of each different file. In this case, I'm just going to do 5 files, test file 1, 2, 3, 4, 5, because we're using 1.5. But this is still brace expansion because it's expanding the arguments. So we're basically giving touch test file 1, touch test file 2, all the way to whatever your limit is here. So if I execute that, watch the middle window, it's my Ranger file viewer. It actually will run and give me 5 new files, test file 1, 2, 3, 4, 5. So now you can see how brace expansion works. I use this all the time when I am making directories, when I'm making files. Using brace expansion is one of my favorite things about the shell. So actually, I'm going to run that again because I need it for my next example. So you can see in Ranger here, I have my 5 test files. So globbing, and DistroTube did a really great video on globbing. I'm not going to get too much into it, but you're basically just grabbing all of the variables or all of the items that meet some condition, or in this case, a wildcard search. You're taking all of them, globbing them together, and then running an operation on each one of those items. It's like brace expansion, but you're doing it with like a wildcard. At least that's my understanding of it. There might be a better interpretation or explanation. DistroTube did a great video on globbing. But in this case, I'm saying remove test file and then wildcard. So each of these test files ends with a different number. I don't want to have to type out the rm command 5 times. I want to do it once. I want to do a one-liner. So I could say remove test file and whatever else comes after it. So any file that starts with test file and has anything else after it, remove it. In which case, that would be, let me change that. So when I run the command, watch this in the middle screen, you're actually going to remove all those test files. All at once. Because it globbed all of them together and said remove all of these files. That's about as much as I'm going to go into globbing for this. So inside of my working home directory, I have cat and notes. So I have a file called notes. Inside this file, I have these, some text here, I have a header, and I have these, checkbox task items. So with bash and certain commands like grep or others, we actually can use regular expressions. I did a whole video on regular expressions. I'll put it in the card, or put a card up there. Regular expressions are freaking awesome. It's an easy way of finding pieces of text, file names, etc. And grep is really great with working with regular expressions. So in this case, this command is saying in double quotes for my regular expression, because it includes special characters, so I need to double quote it. At the beginning of the line, look for, and I'm escaping a dash, a space, and then I'm escaping a square bracket. There's another space. I'm escaping the closing square bracket and anything that comes after it. Give me every line that meets basically a checkbox task item from the notes file. So when I run my script, excuse me. Oh, I need to save it first, my bad. It'll actually pull out, oops. It'll pull out those tasks. Like this. Now, if I change my notes file, and let's say I actually completed a task, now I put an X in there, we're good to go. But if I do my regular expression, I'm not looking for tasks with an X in it. If I run this command, I only get those 2 non-completed tasks. Say you have a bunch of files in a directory. You want to do globbing because you want to pull out all of these regular expressions. So basically all of my uncompleted tasks on a collection of files. You could easily just run grep, this regular expression, and then instead of saying a specific document here, put a wildcard. That basically says run this regular expression search to find all uncompleted tasks on every file in my current working directory. And this is again why some people just use the shell as much as I do, because the shell is super powerful for doing text manipulation and doing things like this. Give me all the items in all of these files. And that's so powerful compared to having to do everything in a GUI interface. So in this case, I could easily change this to be, put an X here, and I want only my completed tasks, and it would give me that as well. And this is actually a feature I use all the time, where I pull out uncompleted or completed tasks out of a document. Another really cool thing you can do is functions in Bash. In Bash, you could define your own functions. You can put these in your bash RC. You can put them in scripts and then call them later. It's a very powerful and useful feature. So in this function, I'm saying function myfunc, yeah, great naming here, and immediately after, no space, put your opening closing parens and an opening brace. You probably want a space after the brace, or before the brace, and then inside all the commands you want to run when you execute this function, a closing brace, that is it. Now we actually need to call the function, so that's when you just say the name of it. There's no parens on this, you just say the name of the function. It displays as plain text, white text here, and that actually calls the function. If I call it, there we go. It's bad practice. Why is it bad practice? From what I've read, it's bad practice to actually use the word function before your function names. So you can see that it looks like this teal color with my syntax highlighting. If I comment that out and then go to the better example, it still does that when you just use the opening closing parens. This is basically defining a function without having to put the word function before it. If I run this, there we go. This is the better practice, is defining your functions with out the word function at the beginning. So with that, that is the most I'm going to cover on just like basic operations, syntax, and general scripting. The actual meat of Bash and scripting in Bash really comes from learning and understanding the built-ins. Grep, sed, awk, cat, echo, all these different things. Learning them, their flag options, what you can do with them. It's an endless stream of learning. But it's basically learning those C programs, the flag options you can give them, what those things can do, chaining them together, piping your output, and then using all this stuff in Bash with those programs to create elegant and powerful scripts to do whatever operations you want to do in your system. Bash is the glue for these C programs, and Bash is really just glue for C. So in this case, you can actually write your own C programs, use those with Bash, and the world is your oyster when it comes to doing Bash and C stuff together. One really good thing that really helps, because Bash is a weird and sometimes abominable syntax and just so many different little things that trip you up, to keep POSIX compliant, or if you want to do Bash, there are options for it, is a tool called shell check. If you're on Arch, you can do, I think, just pacman-s shell check, or maybe it's in the AUR, yay-s shell check, whatever. But shell check, I have mapped to leader S, will actually run a search on your entire shell script and pull out errors or items that are not POSIX compliant in this case, because I'm not saying run it as bash. So if I run shell check, it says clear. Let's try and do a bad example. Let's do -e, because this is actually not a POSIX compliant option. I don't know why it's not picking it up. Oh, it was hating some math stuff earlier. Let's do this. Oh, yes, the tests. It was not liking the tests. Here we go. So if I remove these, or if I just do this, and I run shell check, you'll see it actually gives out, in this line, this is the code. Here's the issue. Here's some suggestions. This is a great tool to write better shell scripts, and it checks things for you. You could either have it check for POSIX compliance, you could have it check to just work with bash. Shell check is an awesome tool. Man, shell check. And it does have some options, and it's just a really great tool. It's really essential for people who are writing bash scripts. And one really cool thing you can do with it is if you have a GitHub repo and say, I have a repo for my Flash script. I've made several videos about it. It's a cool flashcard system in your terminal. And I have it hooked up with Travis CI. So in here, you can see my build is passing. It's only a shell script. This is the shell script. You can see the code here. If it will open and not be slow. So it's all this shell script code. It's a lot to manage at this point. So say you want to have it shell check and then show you, oh, my build isn't passing, and do continuous integration. So I have a .travis YAML file here, and all I did was I said script, fail if any of these, blah, 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 -shell check -s bash. This script is actually a bash script. It's not completely POSIX compliant. That's a goal. That's a goal I'm working for. But you can actually have it be changing or checking for bash or for POSIX, and you can actually run shell check in Travis CI to actually check your shell scripts on GitHub. This is a really cool thing to make sure that your shell scripts are actually, not broken. Excuse me. And what this looks like, if I went to Travis build, I guess I need to actually go to Travis. Where is it? I only have a couple repos on Travis for CI. Here we go. fla.sh. So it'll actually do a build, and it will actually run shell check on my script every time I push a commit, and then tell me if my build fails. You can ignore the fact that it says Ruby here. It's just what Travis does, but this is a great way of doing CI on your shell scripts if you're doing them, like actually hosting them on bash. So that was my basic overview and primer on bash. I will actually leave this example file as a GitHub gist on my GitHub. I'll post a link to this in the comments section and pin it for you. I'm just going to leave everything commented out so it's easier. But I'm going to leave this as an example for everyone. Yeah, let me know what you think. Let me know if I got anything wrong so we can clarify for everybody and so I can learn too. Let me know what you think in the comments below. If you've done anything really cool with bash, let me know. And yeah, that's it for now. Thanks for watching. And before I go, big shout out to my Patreon patron, Devin. He's the first patron on my Patreon. You can find the link in the description. Thanks for being a patron, Devin, and thanks for contributing to the channel. All right, that's all for now, everyone. Thanks for watching.